To run one little 40 megabyte app, a virtual machine boots an entire 2 gigabyte operating system first. It spins up a whole second computer in software just to run your program. Last video, we packed our app into a box, a container. So here's the obvious question: why commission an entire cargo ship just to move one box? That's VMs versus containers, explained with ships versus boxes. Welcome to Docker Explained, Video 2. As always, no prior knowledge assumed. And stick around for stop 4. It's the one line that separates people who get Docker from people who don't. 6 stops on the water. First, a ship per shipment, what a virtual machine really is. Second, boxes sharing one ship, what a container really is. Stop 3, the myth that a container is just a lightweight VM. Stop 4 is walked. It's the real answer, and it's the whole point of this video. We'll earn it. Stop 5, the cheat sheet, ship versus box, side by side. And stop 6, the bonus, where we time a box against a ship, live. One analogy the whole way, ships and boxes. Every idea maps to the harbor. Keep your eye on stop 4. It stays locked until we've earned the answer. Quick recap from last time. A container is your app, sealed into one standard box that runs the same way anywhere. But we never asked the next question: what is that box actually sitting on? What's underneath it? Answering that is the whole job of today. Stop 1, the old way. One whole ship per shipment. That's a virtual machine. To carry your cargo, a VM brings an entire ship, built from scratch for that one load. It brings its own engine, a complete operating system, its own crew, its own kernel, running all by itself, and its own fuel, a chunk of RAM and CPU reserved up front, whether you use it or not. A virtual machine is a whole computer and software, engine, crew, fuel, and all. And a ship is heavy. Each VM carries a full operating system, so it weighs gigabytes per app. It takes minutes to boot, like docking and crewing a real ship. And because each one is so big, only a few fit on a single machine. Think about what that means. You wanted to move one box, and to do it, you built an entire navy? Quick prediction before the reveal. You need to run 10 apps on one server. Do you launch 10 separate ships, 10 full operating systems, or drop 10 boxes onto one ship they all share? Hold that thought, because the answer is the whole idea behind containers. Stop 2, the new way. Boxes share one ship. Instead of a ship per app, you drop all your boxes onto one ship, and that ship is your actual machine, the host. Here's the key. They all share its one engine. That engine is the host's kernel, the core of the operating system, and it's already running. So there's no second ship per box, no second operating system to boot. They just share the one that's already at sea. Let's draw the same machine 2 ways. On the left, virtual machines. Every app sits on its own full operating system. Those stack on a hypervisor, and that sits on the hardware. The operating system is repeated for every single app. On the right, containers. The apps sit on the Docker engine, which sits on one host operating system, a single shared kernel on the hardware. Same apps, but the OS is shared, not copied. That one difference: the VM repeats the whole operating system per app, the container shares it, is the entire story. And that's why containers feel like magic, seconds, not minutes. A ship, a virtual machine, takes 30 to 60 seconds to start because it boots a whole operating system every time. A box starts in under a second because the engine is already running. It just starts your process. Same hardware. You fit a handful of ships or hundreds of boxes. Which brings us to the lock stop, number 4. One more prediction. So a container is just a tiny, lightweight virtual machine. A smaller ship, right? That sounds right. Hold your answer. Here's the myth, and almost everyone believes it at first. The myth a container is just a smaller virtual machine. It feels true because both isolate your app and both feel boxed off. But here's the reality. A virtual machine virtualizes hardware and runs its own kernel. It really is a second ship with its own engine. A container virtualizes nothing. There's no second engine. It shares the host's one kernel and simply fences off your app. That's exactly why it starts in milliseconds instead of minutes. There's no ship to build. And that unlocks stop 4. A container virtualizes nothing. It shares the one engine. So if boxes are so much lighter, why do ships still exist? Because the weight buys you something, isolation. The ship's hull is heavy, but it's a hard wall. Its own kernel means stronger separation, which matters for untrusted code or wildly different systems. The box walls are light and fast, a softer wall that shares the engine. But they're good enough for most apps and far cheaper to run by the hundred. And honestly, it's rarely either or. In the cloud, you usually run boxes on a ship, containers inside a VM. They're partners, not enemies. Here's your decoder ring, ship versus box on one screen. Weight, a VM carries a whole operating system. Gigabytes. A container shares the OS, megabytes. Boot, minutes versus milliseconds. Isolation, a VM is hardware level and strong. A container is process level and might. Density, a few VMs per machine or hundreds of containers. Pause and screenshot this one. It's the answer to the most common Docker interview question there is. Let's prove it. We run time docker run alpine echo high. Alpine is a tiny Linux box. Outcomes high, and look at the clock. 0.7 seconds, start to finish. The box was dropped on the ship in under a second. Now compare booting that same Linux as a full virtual machine takes 30 to 60 seconds. Same isolation job, roughly 50 times faster to start. Why was it instant? 3 reasons. There was no operating system to boot. The engine, the host kernel, was already running. Docker just started your process inside a fenced-off box. And nothing was virtualized. No second ship was ever built. In one line, the ship was already at sea, and we just dropped a box onto it. Here's the whole video in one picture. A virtual machine ships a whole computer, engine, crew, fuel, and your app. A container ships just the app and shares the engine that's already running. That's the difference, and it's why the world moved to boxes. Challenge before you go, containers all share the host's one engine. So what's the catch? What do you give up for all that speed? Drop your guess in the comments. Next video, we crack open the box and look inside. What a container really is, explained with a sealed cargo box. We'll see exactly how one process gets fenced off to think it owns the whole ship. See you on the dock.